Hello, my name is John Metzcar. I'm a graduate student at Indiana University in the Math Cancer Lab, studying bioengineering and informatics. Today I'm going to be presenting some slides, kind of walking through step by step these slides so that individuals who are using Mac OS or using Apple products can install PhysiCell. So my hope, this is work that was done by Randy Heiland, and I contributed as well. This is a general install guide for PhysiCell on macOS. And also there are some particulars that are relevant for the, at this point in time, upcoming PhysiCell workshop, 2021 workshop. So let's see what happens. So as a brief overview, we're going to be stepping, first note that if you have a newer Apple product using the M1 chipset, things might be a little bit different, so please contact us for support. Moving on to the general setup, we provide kind of a minimal setup and then a traditional setup that includes additional pieces that are used in kind of like a typical PhysiCell development environment. So we've got, we need a compiler. In order to get the compiler, we need a package manager. We recommend using Homebrew, and that's what we specify in this tutorial. And then we need to download the source code and show that we can compile it and that it'll run, execute. In addition, a lot of our features, some of our inbuilt features might use Python 3, plus a lot of our visualization and analysis, and the community visualization and analysis is written in Python. There are other components. Python ends up being very important. There is a newer set of models with intracellular modeling. We'll have to download the components for that and show that that can work. And then ImageMagick is used for image processing to make animations. And then we have a new product called PhysiCell Model Builder that enables graphical user interactions with setting up PhysiCell models. And then of note for the workshop in particular, we are requiring COPASI, which is a model simulator for often intracellular models that uses a language called systems biology markup language. So we, for the workshop, are going to need that to edit that SBML. So note that I'll be copying and pasting the boldface commands directly into the terminal on my computer. While I've installed almost all the components on my computer, as I'm an active, I'm part of the group, and so I need these pieces of the tool chain to work. So my output won't be the same necessarily as what you would see for a first install, but this guide includes screenshots of what that would look like. And my intention here is to make sure that you know where to look within this document for the commands. So note that your experience will be different than what you're seeing here. And also, of course, this is a static document. So in particular, the PhysiCell model builder, if we find something that we need to change, the version number may change. So you might have to modify this install guide slightly for that. So let's get to it. So the compiler that comes with Apple computers is not OpenMP enabled, and that's a requirement for running PhysiCell. To get the compiler that we need, GCC, you can, we use Homebrew, which is a package manager. To install Homebrew, you would do something like this. These are all live links. So go to Homebrew, and then this will copy to buffer, move to a terminal. I'm not going to execute this. I already have Homebrew. So I'm going to, well, that's not very, this is riveting video. There we go. Switching back to our document, you can see here that exactly what I just did. Slightly different color from the, I use a white background right now. And then if you did execute it, I'm going to turn off my video to make sure everything is set. So great. If you did execute it, you would see output similar to this. And then once you have that, that'll enable you to install GCC. So you copy, Command C, back to terminal, and then execute it by hitting return. Again, I'm not going to do that right now. And that will install GCC. It'll take a few minutes. I think in my experience, it takes 20, maybe 30 minutes, and it does really depend on your setup. And here you'll be able to see my GCC by executing this command. I have 10. Right now, 11 is out. 10, 11, they all work. And I can demonstrate this as well. Right. This is the expected output. Now we need PhysiCell. Now we have a compiler. So there is a quick start guide that you can use as well that supplements these slides and this video. In order to run our make files, you need to set a user variable. And what this slide is, so this, I can copy paste this, and that'll make this particular session have that. I'm not going to do that because I need 10, not 11. But what we recommend is that you actually put it in your bash profile or your Z shell environment. So Apple currently is making Z shell the default shell for interacting with the operating system. Some people may, some of the users who are installing this may also use bash. I know I still use bash. Either one is perfectly fine. We have documented that there's slight modifications to installing if you, depending on which one you use. So in order to, and I'm going to use the bash commands in order to copy this to your bash profile so that this variable, this shell variable, is always set. So I'll move to my home directory. It was already there. And then in my case, I already have a bash profile file, but the touch command won't change that. If you didn't have a bash profile text file, it would have created it. And same thing for the other command. And now these will add, copy paste this, and this will add it to your profile. I'm not going to, in my case, I have 10, so I'll show that in just a second. So I'm gonna, this echo command tells it to print a screen more or less. So there I have GCC, I have that PhysiCell variable set. And if you insult 11, you would see exactly what's here, this 11. All right, now we should test it. So I'm going to download this release. If you followed the other command, it would take you, I think, directly to the bottom. Well, that didn't work out how I wanted it to. Okay. You're getting wonderful, wonderful time getting to see me fumble with how to download that. I'm going to follow the other one. Great. Now it's downloading. Oops. So that's downloaded. So I'm going to switch to downloads. Okay. So that command made me change where the terminal window was pointing in terms of the file structure. This command will verify that the file is present. It will list it. Oh, well, isn't that exciting? Live video, folks. So I figured out what was going on. I have automatic unzipping set for my computer. So that zipped file that this command is looking for doesn't exist, or it's already been unzipped. So this command is where you would move the zip file to your home directory. I'm going to modify that slightly. So I'm going to move, I already have this PhysiCell, so I'm going to move PhysiCell to my home directory. I'm going to execute the commands from the download. So it could be slightly different. So my next command is to change into this directory. Great. Now I should be able to continue with a tutorial. All right, so we've got make. So now it's compiling the default program, default sample, which is the heterogeneity sample. This is output, and this is live output that should be similar to what you on a first install would see. I'll wait for that for a second. And so here we got the heterogeneity, and here's the output that this is all output that Randy made. And once it's made, this command will execute the executable, the binary file that's generated. All right, so we're ready. Great, and it's running. So you see this output. This is about setup. And then now the simulation is running, and you can see snapshots with bits of information about how where the simulation is at in terms of time, some output regarding the simulation itself, such as the number of agents. So the number of agents here is changing with time, and then how long it's taking to execute. So next step. So I'm going to do Control-C and cancel the simulation. And that's a keyboard command. And then I'll look at the output. So can't see this, but I'm hitting Control-C. That kills that process. Now ls output. And this is all the output that was generated while it was executing. And what you can do to confirm this is to navigate to the use however you'd like to navigate to output. I'm going to use the graphical interface. There's ways to get it so that you might be able to do this a little bit more smoothly. And this is the initial, so you can even see on the preview that this matches roughly the output that Randy has provided. And then you could play with it and get down to, this is what the simulation looks like as it continues. Let's see what happens. Aha, yes, you can see all the tabs I have open now. So the simulation executed correctly. All right, so the minimal setup has been completed at this point in time, and we're going to look at the getting Python. We use the Anaconda distribution of Python. I'm going to let that stand for itself. You can view that in your own time. So let's see which Python I have. I'm going to use this terminal window for the Python. Great, I already have it, but you may not. This will allow you, if you just execute Python, you'll get an interactive Python shell. I always forget this command. Perfect. So now this is where you'd want to look at getting, here we go. I mean, it's just right there. I can start this download immediately. And this is the graphical case. We've documented using the graphical installer and the command line installer. Looks like the default here is the graphical installer, and I've used the graphical installer myself. I believe Randy has used the command line installer in the past. So to briefly go over the command line instructions, you would, if you downloaded the command line installer, you would take this command directly from the PDF, this PDF or PowerPoint. In my case, I wouldn't run this anyway, and this program, this .shell program, isn't on my computer. But I would enter it, and it would execute. And then I'd follow all the prompts as documented in the PDF. So you would want to do yes and accept the license. Note that you would receive a warning, and we actually want that, and that's covered again in the graphical overview. And then in order to actually use this is important that you would need to close and reopen the terminal basically in order to get the Python environment running. So you can see that here. This base means that I already have my base Anaconda environment running. Mac deactivate. That's not how you spell it. Deactivate. And then you can that'll invoke the Conda environment and cause this signifier to pop back up. And I already did the which Python, and you can know that on my system it's already installed, and so you would see something similar if your installation ran correctly. So here's what the graphical client looks like. It's very well documented here. I think what I'd like to really note is that it's very important that you do install for me to make sure that things run smoothly. And then just follow the installer. In my case, installing Anaconda, the graphical, I haven't installed it via command line, but the graphical method, it took a while. Again, it's similar to sort of like Homebrew and GCC. There's maybe a lot of downloads, a lot of execution, and just a lot of power to execute it. So expect it to take some time, but not like hours. Perhaps tens of minutes. And in Randy's experience, I guess it took longer than a minute. So, but much less than an hour. Great. And so then either way, now you could execute which Python, and you should be coming up with the same that Python is present, and that is Python 3 from Anaconda. All right, and we're going to test building an intracellular model. So using the make command, using a make command from makefile, I'm going to switch back over to our PhysiCell terminal. Make reset. That'll get rid of the heterogeneity example that we compiled earlier. And this command will tell us what all the sample projects that are included in the PhysiCell download are. And what we want is this one. That will be documented here as well. And now next you'll type and you'll next type make in order to actually get it to make. And then you'll see this output here as it downloads. There we go. I need to highlight that. As it downloads libRoadrunner, which is required. So the intracellular model uses a set of ordinary differential equations to solve a model of intracellular interactions. And I'll turn this back on. In order to do that, we've linked it actually, in particular, Randy, Heiland, Paul, and Furkan, in collaboration with collaborators at the University of Washington, have linked Andy Samoji, have linked this with our PhysiCell sort of setup, and now we're able to link two different solvers, the PhysiCell model and all of its components with the libRoadrunner, which is an OEE solver that uses the SBML language that I mentioned earlier to solve intracellular models. Okay, downloaded, installing. Now we're actually compiling. All right, great, ready to go. And you can see here documented all the output. I'm going to clear this so that it brings it to the top of the screen. Great. Oh no, there's an error. Ah, good thing that's documented. So we need to add another environment variable. So this will be a good demonstration of this. Great, that added it to the shell. The current instance of the shell running. Now I'll be able to execute this without generating an error. So I'm gonna go ahead and I hit Control-C to stop that. You can see that our output matches roughly what was documented by Randy. Executes fast. Let that go. And we're noting here that you can look at the SVG files. I'm not going to do that at this time. Instead, I'm going to make sure this time I haven't added this to my bash profile. So there we go. So you can just directly Control-C or Command-C and Command-V to paste directly into the terminal. You can tell that at one point in time I did use Windows. And for this, now it's permanent in my bash profile, but I'd have to restart it to actually because you need to reload the shell in order to reload this modified bash profile. I'm not going to do that right now. So we're getting close to the end of the requirements. So ImageMagick is a command line image processor. Here's your command here. This, just like with GCC, we recommend using brew to install ImageMagick. I've already had ImageMagick installed, so I'm not going to execute this right now. But you'd hit enter and you would get output similar to this. It won't take very long. And then this convert is a program that comes with ImageMagick. So if you don't have ImageMagick, convert won't be there. So the which convert command will not return this location. But on my computer, and once you've set it up yourself, you'll see that it's there. It was successfully installed. And then here in this portion of the quick start guide, in the quick start, we do provide some basic instructions on how to use ImageMagick and some examples. And also it's in a make command to so these you can just execute some make commands as well to do some basic ImageMagick image processing. Again, just to emphasize that all these are directly you can copy paste directly and execute them. In my case, I don't expect that command would work. I didn't let that simulation run out that far. Great, now we're to the PhysiCell model builder. So I'm going to download the source code. I'm going to go ahead. Why not try this? Let's see what happens. So I need a shell. I need a terminal in downloads. I'm going to change to downloads. Now, yeah. So that's because the model builder has already been unzipped in my case. So this command, though, I expect will work. Perfect. So now I'm in the files. All of this can be done, well, I can't. You can view these graphically through the graphical user interface that Apple supplies as well. If you want to look, if that's what you're more used to in terms of looking at a file structure. This command, though, this will actually have to be executed at the command line. And now we have the model builder. Ta-da! I'm very excited about this. It's really cool. And it'll be great for the workshop. So again, this beautiful tutorial developed by Randy, you can see that his output matches what we're seeing live, and can confirm that we in fact do have the correct setup. All right, now we're to I guess kind of some bonus slides that are outside of the sort of what we recommend as maybe needed for a standard development environment for PhysiCell. So SBML, as I provided in this slide. So COPASI is a simulator that uses SBML, which stands for Systems Biology Markup Language, to represent this. The SBML represents intracellular models. It can be used to represent other things as well, but in the case of COPASI, it's primarily intracellular models, ordinary differential equations, stochastic differential equations. We use in PhysiCell SBML to represent ODE models, as well as flux balance analysis models. And so that ODE sample model that I just went through compiling and running, the intracellular model that was running within the PhysiCell environment and program was written in SBML. So during the workshop, we're going to be, in particular for Khan, is going to be demonstrating how to create that and edit, create an intracellular model and edit an intracellular model using SBML with COPASI as the editor. So it's a graphical user interface to edit SBML. Note that there are other ways to do that. But right now we're supporting COPASI for the workshop. So to get COPASI, you as macOS users, you'll want to download this. I'm going to emphasize this. So there's multiple bindings available for COPASI. What we need for the workshop is just the graphical standard graphical client for macOS. That'll download, it's not too big. And then this installation is relatively simple, simpler than the graphical, installing the graphical client for a graphical package for Anaconda. So download the package, double click on the image, and you'll be able to start the installation. However, because of Apple security, you'll have to go through, I know I had to go through this process where I go into settings, then into security and privacy, and then in the general tab, I got this error message. I got an error message saying that I couldn't run this package. So I went to security and privacy and then was able to just click this. So let's demo that. Let's see how oh my, now you're really seeing the truth. Okay, so that's fine. And then it's here where you run into the problem. So you can click OK. And then so we don't have settings pulled up. Settings. I always have to do this. There, security and privacy. Now I'm already on general, and now I can click open anyway. And now my installer is running. And for you, just go ahead and continue through the entire process. It's straightforward, and you can just accept the defaults. Also, so that's the end of what is required for the for installing PhysiCell in the traditional developer setup, as well as what's required for the workshop. In addition, just kind of to make the point that often people use integrated development environments for, or you need some kind of editor, text editor. Please use whatever you're comfortable with. And if you don't have one that you have used in the past, if you're new to this, Visual Studio, VS Code from Microsoft works well. I know plenty of people in the lab use it. It's free, but please find what works for you. Ask around. If you find something great, let us know. And then version control is very typically used for coding, in particular Git. Of course, if you already have a system that you're using for version control, please keep using it. If you're new to programming, we recommend Git, and a search for Git Mac install will yield helpful results. You might even have it already through Xcode. And then for sharing code, as you'll notice in the support pages, the PhysiCell project uses SourceForge and GitHub, and many folks use GitHub as a way to share code and as an offsite way of handling version control. And you can use multiple visual clients if you don't want to use the command line interface for using get. So for support, just to go over it, if you haven't joined the Slack channel, please do. These are live links that will take you there. And if you have any trouble, please reach out. Randy, Heiland, and I are both, we contributed to this or made this. And so we'd be happy to help out if you are having any problems with installing a macOS in particular. And Randy is really very experienced with all installations, Linux and Windows, etc. So problem tickets go to SourceForge, and please follow us on Twitter. And of course, we'd like to thank all of our funders that have made this, made the development of PhysiCell possible, made our projects possible, and in particular made this upcoming workshop possible. So thanks for listening, viewing this video. If you have any further questions, please reach out. Please share your triumphs and struggles so that we can learn from so the whole community can benefit and learn from your experience, and we can share in this together. Thanks.